All right. So this first notes is all about properties of triangles that you probably didn't know. They're just like obscure properties that helps you understand triangles. Now, when I'm looking at this first example here, this triangle, how many parts does it have? How many how many parts does a triangle have in general? It has 6, right? It has 3 angles and 3 sides. Now, looking at this triangle, say I changed the size of this angle C. I changed that 50 to maybe a 70. So I made it bigger. What side length do you think that's going to affect? So if I'm making this angle bigger, right? So let's see. Instead of having the line where it is, I extend it outward this way. What line increases in length? AB. So that is what is called an angle-side relationship. The angle affects the side across from it. And in fact, the largest angle is across from the longest side. Also, the smallest angles across from the shortest side, and the medium angles across from the medium side. The angles affect the side lengths, and the side lengths affect the angles. Now, I know it's hard to kind of visualize for some of you the concept of across from. So C is across from line AB. It's hard for you to visualize that. So I use what is called the cover-up method. What you do is you take your hand and you cover up whichever angle you want to look at. So maybe the smallest angle. And the only side showing is going to be the shortest side. So if I cover up C with my hand, what's the only side you can see?
I can still see it.
I'm covering up angle C. Not letter C, angle C. What's the only full side you can see?
I know you can still see it.
Oh my God. What is the only full side you can see?
AB.
AB, that is the side across from it. So, in this example, it says list the sides from least to greatest. What is stopping us from immediately doing that? What are we missing here? You don't have the measures of the sides, right? But we just learned that the measures of the angles can tell us what is least and what is greatest side lengths here. So if I cover up the smallest angle, which is what? C, what is going to be the smallest side? AB. So that's what I list first. What is the medium angle? Angle, tell me this medium angle. B, right? It's between 50 and 70, so 60 is the medium angle. What's the only full side you can see when you cover up B? AC or CA. That's the medium length side. And what's the largest angle? A, cover it up. What's the only full side you can see? So that's the longest side. And you're done.
Shortest, medium, and longest.
That's what it says, least to greatest.
Oh.
Least to greatest. All right, you guys try example number 2 there. What is it's asking you to find the angles this time. So list the angles from greatest to least. So this time we're asked to list the angles from greatest to least. So what is our biggest angle, Abby? Ooh. What is it? A. No. What is the longest side? The biggest side? AC. So cover up that entire length with your hand. And what's the only angle you can see? B. So that is our biggest angle. And then what is our medium angle? Not the right class. Parker?
C.
C. Yes. So 6, this line right here, AB, is our medium side. So cover it up. The only angle you can see is angle C. And then what is our smallest angle? Reese? A. Yes, because it is across from the 1 there. Any questions on that? Do you understand what we're doing?
Yeah.
Okay. So now that we understand the relationship between sides and angles, now we're going to figure out if three numbers can create a triangle. So, in order to test if 3 numbers can be a triangle, there's what's called a triangle inequality theorem. Now, the triangle inequality theorem states that the 2 shortest sides of a triangle need to add up to be greater than the third side. Now, let me show you what this means. So say I have 3 lengths. They're not going to be straight. Right? Say maybe this is, well, this is 3, this is 4, and this is 5. What are my 2 shortest sides? 3 and 4. What is 3 plus 4? 7. Is 7 greater than 5? Yes, so if I line these sides up, right, 3, and then I add on a 4, is it bigger than 5? Well, yes, it is. And in fact, it did already create a triangle. We saw that. But say instead I had lengths of 1 and then maybe 2. Is 1 plus 2 bigger than 5? No. And in fact, if I try to make a triangle out of this, are those side lengths ever going to meet ups to create a triangle?
No.
No. So this is just a numerical test to make sure that 3 sides can form a triangle. That's all that this is. So let's try it. We have 6, 7, 8. What are my 2 smallest? 6 and 7. So I add 6 plus 7, and it has to be greater than 8. So what is 6 plus 7?
13.
Is 13 greater than 8? Yes. So yes, this does form a triangle. Does that make sense? No?
No.
No?
Don't pay attention. You do it again.
So you add together the 2 smallest, 6 and 7. And they have to be greater than the third to make a triangle. So we have to check, okay, what is 6 plus 7? Is 13 greater than 8?
Yeah.
So these 3 numbers can form a triangle. That's all you're doing.
Okay.
So you guys try B and C.
What if it's even?
No, it has to be greater than.
Okay.
So if it's even, it can't form a triangle. So you guys try B and C. Did B form a triangle, Jamar?
No.
No, it did not. Why not?
Because it's less than 4.
Right. What is 1 plus 2? And 3 is less than 4. So no, it does not form a triangle. What about C?
No.
Renalica? Why not? Right. Good. 15 is not greater than 15, so no, it does not form a triangle. Now, sometimes knowing that the 2 smallest have to add up to be the largest, sometimes they'll ask us to find the range of possibilities that a third side can be when they give us 2 sides. So in this problem, they give us 5 and 9, and we have to determine, okay, what could the third side possibly be keeping in mind that the two shortest have to be longer than the third. So this is how you do that. You subtract them and you also add them together. Now when you're subtracting them, you always subtract the larger number first because we don't want it to be negative. So we do 9 minus 5, which is
4.
and then we do 9 plus 5, which is 14. So, boom, we have our answer. The third side has to be between 4 and 14.
So it's always going to be less there?
Yes. Now let's take a look at what this actually means. So if I tried to have 4 be the third side of 5 and 9, our two smallest are what? If I'm choosing 4 as my smallest side. 4 and 5. So what is 4 plus 5? Is 9 greater than 9? No. So 4 is the lower boundary for what our third side can be. It can be a little bit bigger than 4, but it can't be less than 4. Otherwise, the two smallest won't add up to be greater than the third. And then 14, if 14 is our third side, well, 5 plus 9 is equal to 14. It's not greater than 14. So our third side cannot be 14 either. So that's why it's between those two numbers. It can be anything between there. 5, 6, 7, 8, 9, 10. So sometimes they'll ask you, they won't say, oh, what's the range of possibilities? They'll say, give me a possible third side. And then you'll just have to pick any number between 4 and 14. Does that make sense? All right, you guys go ahead and try B. Go ahead and try to find the range of possibilities between 10 and 11. What range did you find, Ben? Yes. Our third side has to be between 1 and 21 because 11 minus 10 is 1 and 11 plus 10 is, oh, not 20, 21. So these are our range of possibilities. Any questions? Okay. So last thing before you can start your Go Formative. Now that we know how to figure out if three numbers can form a triangle, we're going to learn how you can use side lengths to classify a triangle based on angles. So anytime they give you 3 sides and they say, okay, is this a right, obtuse, or acute triangle? All you have to do is plug those numbers into the Pythagorean theorem. So if you plug 3 numbers into the Pythagorean theorem, a squared plus b squared equals c squared, and your a squared plus b squared is equal to your c squared, what type of triangle do you think this is going to be? Right, acute, or obtuse? So a squared plus b squared equals c squared. I plug 3 random numbers in and both sides are equal to each other. What type of triangle is this? Oh, I know you know it. You all know it. What is the only triangle Pythagorean theorem works on?
Right.
Oh, it's a right triangle. Man, you guys are dead. You guys are all like, let's go home and take a nap. We're almost done. All right.
My brain is full.
Okay, so I want to skip the middle one because the last one is almost easier to think about. If you plug in a squared plus b squared and it's less than c squared, so c squared is much bigger, what type of triangle do you think this is? So C squared is much larger than your A and B squared. What is created across from the C? Oh, an obtuse angle. So what type of triangle is this? Obtuse triangle. And therefore, when A squared plus B squared is bigger, so they're just a little bit bigger, what type of triangle is that? An acute triangle. So the Pythagorean theorem can tell you what type of triangle it is. So let's try it. 8, 9, and 11. Which ones do you think have to be my A and B?
8, 9.
Yes, 8 and 9. Why? Yeah, they're the smallest. So we have 8 squared plus 9 squared, and we don't know what it is yet, to 11 squared. So what is 8 squared? And 9 squared? And 11 squared? Good. And what is 64 plus 81?
145.
Good. What is 145 in comparison to 121? Bigger. So which type of triangle is this? Acute. Good. You guys try the second example. So, what type of triangle do you think this is, Brandon?
Right triangle.
Yes. Why is it a right triangle? Yeah. 9 squared plus 12 squared, that's 81 plus 144, that's 225. And 15 squared is 225. So the only thing that satisfies the Pythagorean theorem is a right triangle. Any questions?